Enough of this nonsense. Let's talk about changing the default setting on sinusoidal functions. So we talked about our base models of y equals 1 sine of 1x and y equals 1 cosine of 1x. Our default settings have an amplitude of 1, the middle is at 0, the period is at 2 pi. They have different, what I refer to as starting points, even though the graphs go on forever and won't correct. I think of sine as starting at the mid going up and cosine as starting at the top and then falling. So then, because all the problems go in, all the corresponding points go in the same order. This is what we want to investigate. I want to do some modifications to my sine and my cosine. I want to change the number in front of the trig function, the coefficient of the trig function itself. I want to change the coefficient of x, and I also want to include some addition and subtraction. So I want a sine of b times x minus c plus d. My default setting is that a and b are equal to 1. My sine here is 1 cosine of 1x, 1 sine of 1x. Our default c and d is 0. That's why we don't see them up here. So our default cosine looks like 1 times the cosine of 1 times x minus 0 plus 0. So the default for A and B is 1. The default for C and D is 0. Default for values. So your default values, A and B are 1, C and D are 0. That's why we didn't see them when we were drawing our base model graph, entry-level graph. Sinusoidal graphs dx. We want to figure out what changing the values of A, B, C, and D do. Changing the default values of A and B and C and D. Changing these values, what effect does that have on the amplitude, the mid, the period, where things start? When I say start, I mean what's going on when x is equal to 0. We want to know what's going on, what effect changing these values A, B, C, and D have on these 4 things: the amplitude, the middle, the period, and the start. It's like, so for start, for sine, we're going to think about it as the mid going up. And for cosine, we'll think start at the top. Like what's going on at x equals 0. It's one way to think about the start. Now to do this, I recommend a graphing calculator. The graphing calculator I recommend is definitely not the TI-84 for this particular exercise, and definitely is Desmos. So you can set up both sine and cosine with different values for A, B, C, and D. You can set an equation up with sliders that you can adjust by sliding, or so here we are adjusting, and we can see what's happening when we change the values. Or you can just try plugging in, typing in different functions. So I could say y is equal to, let's say I wanted to just take the sine x, and I just want to see what happens if I change this to a 2. So you can either just go in and manually change things, or you could set up a big fancy calculator with slider. And then you could just set all the sliders in motion. And just kind of like trip out for a little while. It's like really jumpy. It's like, oh, right, B has bigger steps. I put steps in B at 0.5 there. This will smooth it out. Otherwise, we're gonna look like, who's the guy that shot Mad Max and would put like pieces out of the film so it would look like jumpier? That's a little bit smoother. Whoa. Oh, we can? Oh, shit. Wow, I learned something today. I was today years old. That just makes it really small though, doesn't it? If you just put in a letter when you type it in, so when you type in the y equals a sine, it'll ask a sine of x. It'll ask you if you want to add, if you use a letter K. Yeah. Well, you don't want to add a slider for x because x is going to be, you don't get to use y or x as part of your sliders because those are the values that you're plugging in. See, it's not going there. Now it's going nice and smooth. That's a good question. Let's figure out which one is making it go up and down. Let's pause all these. Yeah, it was a little bit frenetic. Let's hit B and see what's happening. So B was not making it go up and down. What's B doing? It's compressing it. That's a great description. It's compressing it and then stretching it and then squishing it in and then stretching it out. So it looks like B has control side to side. Is anything happening vertically as we scan through all these B values? No, it's the values are changing, but where's our top, middle, and bottom, those are all staying the same. So it looks like B is in control of the stretch and compression. What was A doing? A looks like it's adjusting the amplitude. Probably why I called it A. Someone said the volume, that's a great description because it's like quiet. Now it's louder and now it's quiet. Then it kind of flips backwards. Because no, it's like green and then orange and then I flip it over. Now it's green, it's like moved over. It flips over. So it looks like A is controlling the amplitude. What is B controlling? And what of our default settings is being changed here? The period. We're changing how much it stretches or compresses. So we're changing how far it is between two top points. So if I pick two tops here, we're at negative 2.68. The next top is at 0.55. If I change B to a larger value, now this top point is at -4, and this top point is at 0.55 still. So when changing the value of B has changed the period. What does it look like C is doing? Anyone want to speculate what C is doing? So changing the C is changing it horizontally. So it's moving it back and forth. Are we changing the amplitude or the period? No, you could tell by the way I asked the question, right? You could have been asleep. I'm like, are we changing the amplitude? You're like, No, I heard the tone of the question. No. So what do you think D is going to be doing to all this? It must be moving it up and down vertically. Do we expect the amplitude to change? How about the period? How about the horizontal sliding? No. How about the vertical sliding? You didn't fall for it. I said it in the same tone of voice to try to get you to answer no. It's like, oh, no. And I'm like, oh, how about the vertical sliding? And you're like, oh, that's the one that you just asked us about. You can't fool us. TWO spells two. Let's find out. And there it goes. The amplitude is changing. Like the mid, top, and the bottom, those points are all moving up and down, but the distance between them is not changing. So it looks like D controls some kind of vertical shifting. C controls some horizontal shifting. B is controlling the period. And A is controlling the amplitude. The period, oops, let's get a little bit. The period is the distance between two corresponding points. So from a top point to a top point. So let's get B back to 1. Let's get our default. So with B equal to 1, notice that we have a distance between, let's get C down to 0. Let's get there. Okay. So with C at 0, here's our top point, 0, 3.6, and here's the next top, 6.293 or 2 pi. So it's 2 pi later. The distance between any two bottom points, or a mid going up, here's a mid going up, and here's another mid going up. Oh, it's not going to let me land on a mid going up. Yeah, I can just do that. Oh, my C was all messed up too. Here, now it'll let me get. Oh, it's giving me exact values too. Gosh, Desmos, you're such a good graphing calculator. So the distance between those 2 points where we have a mid going up is also 2 pi. Here we're going to have decimals. Here's a mid going down. Here's the next mid going down. Oh, there it is, -3 pi over 2. 2 pi later is pi over 2. So that's the period. How far is between corresponding points? How the length of one cycle? Any questions? Yeah. Is the yes, because the middle is like one of the numbers. So notice if I make a line at the middle, if I make the line y equals d and animate d. So the middle is moving with the value of d. Yeah, the top and bottom, that's why we can get away with calling the middle, because it'll be the same distance from the top to the bottom. Any questions? Yes. C is changing the horizontal shift. So that's going to be, let's stop D and move C. C is going to move everything from side to side, but it's going to maintain the period. It's not going to change the period or the amplitude. It's just shifting from side to side. We come up with boring names for this. This is the horizontal shifts, and D is the vertical shift. This is because I was not at the meeting where they named these things. Because otherwise, I'm like, oh, well, C is clearly hammer time. And D is what makes you jump. No, we're not calling that. No, it's hammer time. That's right. So you could see what the screensaver was doing. It was just changing your horizontal shifts. But the thing stayed the same, so it wasn't multiplying by anything. The screensaver picture stayed the same. Are screensavers even still a thing anymore? Okay. All right, so this is what we want to do. We want to come up, we can see what's going on. We want to figure out more details about how it works. So this week's work is going to be about trying to come up with some description in our own words of what A, B, C, and D do. We know that A is the amplitude, B has something to do with the period, C has something to do with the horizontal shift, and D has something to do with the vertical shift. So we need to see how those things are going, because watch what happens. Let's pause these, move them both to 0 or close to 0. Watch what happens when C goes up. What happens when I increase C? Which way is the graph going? And if but look how it's included in the equation. I wrote X minus C. So if I change this to X plus C, what's going to happen? Oops. There's 2 of them. If they both say plus, then if I move C up, the graph's going to the left. But if it says plus D and I move D up, then the graph goes up. But then when I say C, make these negative, now when C goes up, the graph goes to the right. And when C goes down, the graph goes to the left. What about which one? See, since it says plus D, and then when D goes up, the graph goes up. And when D goes down, graph goes down. That's a good question. Let's find out. So if I make them negative D's, now it's going the opposite. If I move D down, the graph goes up. If I move D up, the graph goes down. It's like trying to catch the middle. No, come back here. Having trouble typing plus. If we change one in cosine, now they're going opposites. Now they're trying to catch each other. So there's a couple of things that are going on here. One thing that's happening is we're shifting things, shifting up and down, shifting left and right. We're also stretching and compressing up and down, stretching and compressing left to right. So what causes stretching? What causes shifting? Well, let's just put all in, change this sign. Oops, I just deleted the sign. Oh, I just killed it. Hang on. Clear. There we go. Any questions? All right, that's what the next quiz is going to be about. Coming up with descriptions of what causes shifting, what causes stretching or compressing, and is there anything different about what's going on when we have horizontal and when we have vertical? We've got 4 things: stretching, shifting, horizontal, vertical. So we've got this little box, one of each. All right, that's going to do it for today. Investigate. You can use Desmos to investigate what's going on. And we will summarize our results on Thursday. That's going to do it for today. I'll see y'all on Thursday. Everybody have a good couple of days. And thanks for playing.